All right, so this is the outline for this talk overall. First, we're going to talk about the app itself that I built to demonstrate these 4 frameworks, and then the API that the frameworks will actually be using. Then I talk about Flask, Tornado, Pyramid, and Django in that order. And then I give some final impressions if time permits. No guarantees there. This talk has gone over time every single time I've given it, so we'll see how it goes. But, you know, please don't fault me too hard if I don't make it. So here's the app overall. It's a simple to-do list. That's the basis of the application. You can register a new account to log in. You can see 3 categories of tasks. You can create new tasks and edit existing ones. Just your basic create, read, update, and delete operations for objects in an application. This is my very plain and crappy front end. It's really just for demonstration purposes only, but you can see registration and sign in. You can see, here's your 3 different types of tasks. You can hit the button and create a new task and see the pop-up window for creating a new task. And these are the routes that each of the backends will use. The plain slash is a home route. You have your registration route, your login, logout. You know, get information for a user by the username, get their tasks, and get a task by ID. That's really all you need to know about that. You'll see those same routes over and over again across the frameworks. And these are those 4 frameworks. I took the descriptions of each from basically their web pages, so this is straight on plagiarism. It's cool. I'm cool with it. So Flask is a micro framework. It's mainly used for small applications. Tornado it's kind of a framework that sits in an ambiguous territory between, like, you can use it for small things, you can use it for big things. Its main claim to fame is that you can do asynchronous work with it in a fairly straightforward way. Pyramid is small and fast, but you can use it to make a project that you intend to have grow up into a larger project that's maybe Django sized, whereas Django is best used for large things and includes a lot of stuff whether you want it or not. Let's start with Flask. Let's start with Flask, okay. To start with Flask, it's like any other Python package you install, you pip install Flask, or I guess if you're using pipenv now, you pipenv install Flask. And you want to get something else like Flask SQL Alchemy and Flask HTTP Auth. I installed those because I want to use a SQL Alchemy database, and I wanted to use HTTP Auth for my authentication, because Flask comes with nothing. So if you want Flask to do anything besides just take in requests and send back responses, you got to get some other stuff to add a little flavor in there. You don't need to do this, but you can if you want to. Set up environment variables. Your Flask app points to the location of your main app object, and then your database URL. This will be used for later on when I connect to the database. But basically, you can set an environment variable to point to a database you intend to use, and then when you deploy your application, it'll point to that database URL. You create your working directory. You can call it whatever you want to. I called mine Flask to do because it's a to-do list written in Flask. And then you create your app.py, which is what this guy points to, which will contain an instance of the Flask object. And your app.config is going to be your central configuration for your Flask application. So anytime you want to do anything that involves changing the configuration of your Flask application, you'll access the app.config object. It will basically act like a big dictionary. There's a little bit more to it than that, but it's not much different from there. It just holds key value pairs. So here's your basic Flask application. End-to-end, this is all you need. Import Flask, make an app object, say, here's the route that I want to access, here's the function that will run when that route is accessed, I'm done. And then when you want to run your Flask application, you say in your command line Flask space run, it'll point to this location, it'll run this, and you can go to the home route of your application and say, hello world, which is always entirely useless. Except for demonstration purposes only. But we can see how we can put together a simple Flask application. Let's add a little bit more to it. Now, at its base, a web framework does what? It takes in requests, HTTP requests, and returns HTTP responses, or HTTPS if you're using secured sockets. But it's the same idea either way. If you wanted to do more than just provide simple responses, you need to add a little bit more to it. In this particular case, we want to add a database. Now, I like SQL databases, so I use SQL Alchemy, Flask SQL Alchemy. If you don't want to use a SQL database, that's fine. Flask is flexible enough where you can do whatever you want as long as you have the right interface. So if you want to use like a Mongo type database, then you can get, I guess there's something called Flask Mongo. I don't know. I don't use Mongo. But it's fairly straightforward. You say, I have my Flask SQL Alchemy package. I'm going to import SQL Alchemy from there, and I'm going to use my database URL, pointing to it in my app.config down here. Then I set up my DB object, which is kind of like my persistent connection to the database, which takes in my app configuration, and then I use that to build my objects, talk to my database, create sessions, anything that I want to do with my database. Moving forward, what you'll see is that Flask, Tornado, and Pyramid all use interfaces to SQL Alchemy. And so you may see the same syntax once or twice, but no more than that, because there's no point to repeat yourself, because, right, we're programmers, we don't repeat ourselves. We try not to. So if you want to define objects in Flask, things that do talk to the database, you take that same DB object defined down here, and you say, I'm going to inherit from db.model. What this does for you is set up once you instantiate your database, it'll set up a table and columns in that table for this one object that you create. Any columns you want to have will be defined by db.column. So every column is a db.column instance. Any data type which you must have in your columns will be defined in the first argument to db.column, and then you can use your keyword arguments in that instantiation to say things like, well, this field should be a primary key, or this field should be able to take null values, or whatever you want to, which pertains to that field in your database. Words are nice. Let's see some code. So here are the two objects that I used in this particular application. This is the task object, which is like your task in your to-do list. And then there's your profile object, which is kind of like your user model. It contains things like your username, your password, that kind of stuff. It looks a little bit cluttered, but the basic idea here is, well, I want to have this ID column, so I say it's a db.column instance. It's going to be an integer, and it's going to be the primary key of my table, etc. If you want to change the table name to anything besides like tasks, then you can even have a dunder table name attribute and set that to a string to whatever you want it to be. So if you want it to be potato, then my task object can be in the potato table, if that's what you want. I mean, it's Flask. You can do whatever you want. Now, these are just classes in Python. So even though you are defining these class attributes, you can still do your normal class stuff, like override the constructor. Down here in the profile object, what I have going on is I'm going to take in whatever arguments that I would normally use to instantiate this class, but I'm also going to set the date join for this profile to be automatically updated to right now, the moment right now when this object was instantiated, and I'm going to also give them this token for logging in later on. Now, unfortunately, I don't have enough time in this talk to go over like authentication and all the various other things you might want to have in your models, but this would be a good way to like give a user a token on when they register, or give them a sign-in date when they join your larger application. Now, being able to define objects is great, but objects oftentimes talk to one another, especially in applications that use users. My users have tasks. Those tasks belong to someone. And so to set that relationship, I need to use SQL Alchemy's built-in stuff for like building relationships and setting columns on objects that refer to those relationships. The kind of relationships you might want to have are things like many-to-many, where like one thing can be owned by many things. It can also own many things itself. You can also have one-to-one, where like the relationship is I am one thing, I own one thing, they own me. We cannot talk to anything else besides each other. And then you can have one-to-many, also known as the foreign key relationship, where it's like, well. And this is best illustrated by a to-do list, where I'm one user, I have many tasks, each one of those tasks only belongs to me and nobody else. To set up those relationships, you use the db.relationship function in SQL Alchemy. And you say, on my many, I'm going to say there's a relationship to my one. And here's the ID of that one. And then on my one, here's a relationship to my many. Here's the name of my many. Here's the name of my one. And then as I set these objects up and assign them to each other, the database will make a foreign key field for me, so that when it actually does the database lookup, it does a join and gives me back all my data. But On the objects themselves, you'll have these attributes like the profile ID, which will point to the profile of the object that owns this task. Whereas my profile object will have a list of tasks that it owns. It makes it very simple to manage relationships in your views, which will come later on. Now, because Flask is a do-it-yourself framework, you have to, do it yourself to set up your database interaction. Now, there are better packages than this one little module that I've written here, but this does the basic thing of like, well, if I'm in development, I can just drop all my tables and create new ones. Or if I'm in production, I just create new ones and go about my business. If I was a better person, I'd use something like Alembic to handle migrations, so like updates to my database, but I'm not that good of a person, so this is what you get. So I wrote my own database management system. I don't advise that you do that in practice. All right, let's talk about views. So views are functions or callables that get run whenever a route or a URL is hit that belongs to your application. Routes are those URLs. And you don't usually have to specify the entire route name, not like domain name, like protocol, domain name, and the URI. All you usually need is the URI, and your web framework, which does many wonderful things for you, will stitch together your domain name and your URI. So all you have to worry about is what you want the naming convention to be in your application, not what the whole URL should look like when someone tries to click on a link. With Flask, you assign your views to your routes by decorating those views with the app.route decorator. You say, this function belongs to this route. You can even specify what HTTP methods are allowed for that function. And then the return value should be whatever you want your HTTP response to be. You don't have to build the entire response yourself, including all the headers and whatnot. You just tell Flask, this is going to be a response object. Handle it as you will. Here's just what's going to be in the body of that response. Here's a very simple view and route. /API/v1, that's like my home route for my API. And then this is just going to list out all of the routes that I have in this application. Nothing more complex than that. This would just be a simple JSON object when it gets rendered. And so with Flask, if I want to render some JSON, I just say JSONify something that is JSON serializable. What I mean by that is that every object that I'm outputting can be represented as a string without any other transformation. But it doesn't look much different from what we saw before with Hello World. It's just a little bit extra, but not that much. Now, of course, there's going to be a little bit more fanciness in any application that you build. You have this database. Database is great. Let's actually use the damn thing. So, first thing to know is that with Flask, your incoming HTTP request gets assigned to this global variable called request. Now, it's only there if you import it, but once you import it, you have access to it in any function that you have in your Flask application. If you don't like global state, don't use Flask. But if you're okay with it, this is fine. If you want to have a route that can handle, if you want to have a variable route, a route that can handle multiple inputs, then you can do that with Flask by setting route variables and then passing those variables to your functions as parameters with the same name. Well, you don't have to have the same name, but it helps. If you want to have any changes to the database, you set up a session by using the session object on the DB object, and you can do things like add instances, delete things, and then commit your changes. Committing, like if you've ever used Git, it's kind of the same idea. You made some changes, now you want to save those changes. To query the database, the objects themselves have a query attribute that you can use to do things like filtering and ordering and grouping and just getting all your things back or getting things one at a time, which is a little bit different in things like Pyramid or, well, really just Pyramid, honestly, where you use a separate session object to query your database. But the idea is the same. You have some query thing going on. You want to get some number of things back from your database. Any responses that you want to build need to be built deliberately if they're going to be anything more than a 200 OK response going back to your front end. Same thing with any status codes and headers you want to set. If you need to set those, you have to set those deliberately in your views somewhere. And so we saw one basic view before. Here's something a little bit more complex. The idea here is I'm going to be creating a task with this view. There's a lot of code here. It's not that bad, I promise. Let's just walk through a little bit so we can understand what's going on here. Right? We have a route set up here where if I go to API v1/account/some username, any username that currently exists in my database, and then slash tasks. What I'm going to be doing here is I'm going to be creating a new task object. I'm going to be sending a post request, and that post request going to that route will be handled by this view function. We good so far? Yes. All right, cool. I like feedback. Lets me know what I'm doing things good or not good. So okay, fine. I go to this route. I have a username. Here's my username in my parameter list. Then I say, hey, database, does this username exist? If it does, let's do some stuff. I did more logic to handle if it doesn't have that name, but yeah, it's a little bit large for one slide. So, okay, I'm sending a post request, which means I'm sending some data along with my request. That data comes through on this request.form dictionary. And I can access the values in that dictionary by name if I know what the names of those fields are going to be. So, for example, if I have a task, I'm setting up a new task, the task has a due date, it might have a due date. It has a name, it might have a note. The creation date is set to be right now. That shouldn't come from the front end. That's, whenever I created the thing. I'm going to be formatting my time string to be something else. I'm going to set the Boolean about whether or not it's going to be a completed task. I'm going to set the profile that it belongs to, make my task object, add my task to my database session, commit the session, send back a response that says, hey, 201, okay, 201 created. You made a new thing. Be happy with your life. And that's a little bit more complex, but still a fairly basic Flask application. Let's see how we do it in Tornado. So Tornado's fairly similar. You pip install Tornado and Tornado SQL Alchemy because, again, we're using SQL Alchemy. Again, much like Flask, Tornado doesn't require that you use SQL Alchemy. There's not a lot of requirements at all, actually. It's very much still do-it-yourself, but with some batteries included. You can set up your database URL as an environment variable. You can set up this session secret if you want to do things like sign your own tokens or sign your own cookies, which become useful when you're doing things like authentication, which I won't go over here. Similar to Flask, you create an app.py file. It doesn't have to be called app.py, but it helps to, for consistency. You would define a port that you want to listen on because you can have one Tornado application run on multiple ports. And then you instantiate an application object with routes and views, and you instantiate the server, pass it the port, and start the I/O loop, the input-output loop. Again, you can have multiple Tornado applications from the same file, from the same project, running at the same time because it supports things like asynchronous processes and long-running sockets like chat applications. So here's a fairly basic Tornado application, start to finish, except I didn't include the view here, but it's the same sort of deal where it's just like a hello world. And so I say, here's my port, here's my main running function, and when this function runs, it's going to set up an application object with all my routes connected to my views in this way instead of being decorators. I'm going to set up this cookie secret here, which is going to come from my environment variable called session secret. By default, it'll just be beefy, because why not? It could be whatever I want. Hello. I set up my HTTP server. I tell it to listen on a given port, and then I start my I/O loop, which runs that server, waiting for incoming requests. Yeah.
My question might be a little too high level.
Sure.
But in 2018, why would you use Tornado? And the assumption could be wrong. Something like async for Python 3, which I know is if you're going really low level, but if you're going really high level, you use something like Django channels. Like, what is the why would someone go to Tornado?
Sure, that's a great question. I would go to Tornado because I don't know async. That's the main thing. Like it kind of makes the interface a little bit simpler for me to understand. Whereas I still have to read the docs on async and async IO and that kind of stuff. And also if you're not using Python 3, right? Why not use Django channels? I'll get this a little bit later, maybe, if time permits, but with Django, you really want Django for just big projects, right? There's a lot of boilerplate code that goes into it where if you're only making a small thing, maybe you're trying to build like a microservice, this would be good for that. Django, not so much. Yeah, good question though. Cool. So much like with Flask, we want to talk to a database. To connect to a database with Tornado, You've got to make a session factory, the session here being your database session, which is different from your session secret, which is for your cookies, which is really confusing. But you make your session factory, and then you attach it to your application object with another keyword value, keyword argument called session factory. Once you do this, you'll have access to a thing in your views called make session, which will pass you a session object, and you can do things like talk to your database and make that an asynchronous process if you wanted to. To define objects in Tornado, it would look pretty much the same as with Flask, except instead of using db.model, you use this declarative base object. The idea is the same. It's your interface to the database. The main difference here is that the base the base object is it's a meta class of sorts where it keeps track of everything that inherits from it. And then you can call on that base object and say, hey, remember all those things that inherited from you? Make tables out of those. And if I was smart, I would put that slide next. We'll see that in a second. In the same way as you did with Flask, you'll make columns with column objects, and you'll build model relationships using the relationship function. And so these are your two models again, your task and your profile model. Same as you saw with Flask, except instead of db.column, it's just column, because you just import column directly. You have this base object which takes the place of db.model. So you inherit from base, you set up your columns, set up your relationships, and it's the same exact code, pretty much. Your views in Tornado will look significantly different from your views in Flask. Tornado likes class-based views. What that means is that you have a class which will handle a specific route, and then for every method, for every HTTP method that route should handle, you'll have a specific method inside of your class. So if you can handle GET requests, you'll have a GET method. If you can handle POST requests, you'll get a POST method. Any routes you want to attach to your application must go in your application config. If you make other views, they are not recognized because they are not attached to routes. Your application doesn't care that they exist. They're just junk code at that point in time. So if you want to have a route that points to a view, it must be in your list of routes and views in your application object. With Tornado, every view that you want to make must inherit from this request handler object. Now, I did a little something extra here, which may not be best practice. I don't know. I like it. What I did is I made a base handler class which inherits from that request handler. The reason why I did that is because there are some methods that I want every view class to have. In this particular case, in this particular instance, I only have one method called setDefaultHeaders, which sets my default headers to be like a JSON application. But I have other things later on which will handle like my inputs and turn them all from byte strings into Unicode, or to being able to set up a method to specify exactly how I want to write my response bodies. And I want that to be accessible to all my views, so I set up this base handler class. You don't have to do it this way. I just think it helps. And so in my actual views, I can focus in on exactly what I want to have happen for that view, and that's it. So particularly here, this is that same info view you saw before in Flask, just the list of all my routes. Here, I say my get method will send this back as a response. One of the main differences is that the return value here is not meaningful anymore. If you want to set up your response body, you must pass it into self.write. This is what becomes your response body. So whatever you pass as an argument to self.write will become your response body. Make sure that you know that going into it. The other thing you can do is you can restrict which methods you want to support in your class as this class attribute called supported methods. If you only want to accept GET requests, then you say, I only accept GET requests, and I'm only going to define this GET request method. It would still have access to the post, put, delete methods if I wanted to, but someone trying to access those HTTP methods from my application for this route wouldn't be able to because they're not supported by this class. With your Tornado views, your request object becomes an attribute of your class instance. It's no longer a global object anymore. It's just, I have this one view, it has a request object, and it only belongs to that class. Any route variables you want must be passed into your view methods as parameters, kind of similar to how we saw it with Flask. Your database interface comes from a session mix-in object, which is kind of this mix-in pattern where you have this other object, which has this very specific methods which you mix into your main class. And then you have this make session method, which will build a database session for you so you can talk to your database with SQL Alchemy or whatever you want to use. As I said before, your responses must be deliberate. You have to pass whatever you want your response body to be into self.write, and then you set your status codes and headers as you please later on. And so here's the start of a more complex view. As I said, with my base handler class, I added a couple things. For one, I want all my views to have access to a database session. So I say in my base handler, use that session mixin. So instead of writing it 4 times or 8 times, or if I have 80 routes, or 80 views rather, instead of writing it 80 times, I just write it once and go about my day. This method prepare is just for preparing all my form data for when I have post requests. And I say, hey, turn those all from byte strings into Unicode. Whenever I instead of using self.write deliberately now, I'm using this send response method that I defined, which will set a status code, set the data that I want into my response body, and we'll do those 2 methods at once instead of me writing the same 2 lines however many times I need to write them. And that same set default headers method as we saw before. Ooh, time's running short. All right. And so moving on, we have this task list view, which is the same thing we saw in Flask, where the job is to create a new task. The difference here is that I have a class instead of a function. And I'm not gonna, I wrote a get method. You can see it in the code base when I show you the link later on. It's not really relevant here. Here's the meat where I create the task. And the one major difference that really needs to be paid attention to right here is this line. This says, so talk to my database when you do this query, and then don't just wait until it's done. You know, go into this I/O loop for your asynchronous process, and you know, whenever it's ready to go, yield this future object back to me, and then continue on with what you were going to do. Which makes it very, very useful for when you have long-running database queries, and you don't want your response. You don't want every other request that would come into your application to wait on the one user who's doing a long query. You just return the response whenever it's ready to go, and you can handle all the requests as they come in. Now, this is, of course, not showing off all the power of Tornado. This is kind of like hammering it into like square peg and round hole sort of thing, because I have the task, the to-do list application. But if I was building a chat app, this would be a very useful thing for me. Let's talk about Pyramid. I did a little bit different with Pyramid, and it comes from a bit of laziness in the way that I teach Pyramid, where I use this cookie cutter thing. So cookie cutter is a package in Python which will build templates for you for different applications that you might want to build, for different frameworks you might want to use. It's not just for Pyramid. There are several for Pyramid, but there's also ones for Flask and Tornado and Django. The difference here is that I didn't know Flask and Tornado that well. I knew Pyramid pretty well, so I just went with the cookie cutter template that it gave me. It also made it really easy for me to do this. So yeah, the idea is more or less still the same, but if you're going to build a Pyramid application, I would suggest you use cookie cutter. It sets up all the stuff for you, like your database interaction. You've seen this kind of stuff before. The only difference is I set up a test DB for when I run tests. In your application root, you also need to change one thing, which is you need to point to your SQL Alchemy URL, kind of like how we did with Flask, to talk to your database in any environment. When you install Pyramid, it also installs some other commands for you to do things like access a shell that is aware of your application, to talk to your database, and to serve your application on a test server locally, which is very nice. When you do use cookie cutter, here's all the stuff you get. Here's what you really need to worry about right now. This init.py. That's where your configuration sits. That's where this function, your main function, sits. And with Pyramid, your central configuration belongs to this configurator object, where you take your settings as, you know, wherever they would come from, and set up your configurator object, and then include anything else you want to include, like your routes or your views or your models, on the configurator object, and then make a WSGI app, and you can go about your business. When you want to connect to the database, you have to make sure you set up this line here, where you say in your settings, set the SQL Alchemy key to be this value, which is your database URL. You don't have to do it this way, but I choose to because of this one specific reason. I'm not a fan of committing important secrets like things like my actual production database in actual like hard-coded files. And with Pyramid, for its configuration, it uses these things, these INI files, this development production INI files. These are not things you can fill in on the fly. Okay, cool. These are not things that you can fill in on the fly. Every value in those files must be hard-coded. And so if you want to have a production database, you can hard-code it into production.ini, it'll still work, but it's not a good idea moving forward. So instead, I just substitute with an environment variable, and it's just one line in this file and one other file. To initialize my database, Cookie Cutter does a nice thing for me. It gives me a database initialization script called initialize.db.py. I'm sure you can imagine what that does. Its only real job is to read my settings file, set up get the URL for my database, drop all my tables, and set up some new tables, and that's it. It'd be great if there was Alembic kind of rolled into this, but it's not. But the cookie cutter template gives me the console script to do this in my setup.py, which makes it very easy to just go in my command line and say initialize DB, and it does what it needs to do. Your views and your URLs. So Pyramid separates these two concepts even more than Flask or Tornado did. With Pyramid, you declare your routes just as routes with names. They're just there. You say to your configuration object, I'm going to expect to handle these routes. I'm going to call each route this name. I use F strings because why the hell not? I have one pattern that I'm using 3 times. I'm going to use it once. To connect these routes to my views, I must use this view config decorator, which says, I know of a route, it exists, it has this name. You will handle that route. You will be rendered as JSON. You will only handle GET requests. And then as with Flask, my return value will be my response body. With Pyramid, the request object is always passed as a parameter into your view function. It's always the first parameter. You should call it request. You don't have to call it request. If you don't call it request, I guarantee you'll be confused. Your URL variables will instead of being parameters now, will be populate a dictionary on the request object. So there's going to be this thing on the request object called the match dict. It's going to contain all of your URL variables. Your database session is also going to be attached to your request object. So instead of having a separate DB object or a separate session, you're going to always say request.dbSession.whatever operation I'm going to do. The other main difference here is that you don't have to commit every change you want to make. The commits in Pyramid are tied to the request response cycle. So once you're sending out a response, Pyramid automatically commits whatever you did for you, which is a good and bad thing. It's good because you don't have to think about committing. It's bad because whenever you want to edit an existing object, well, now you can't commit. And it's not going to commit your changes, which is weird. So you got to do this thing called flush, which is a horribly named method, by the way. Like, why would you call this flush? The idea here is you're going to take all your changes and commit them right now. You can keep doing stuff afterward, but you're going to commit them right now. You're going to flush your changes to the database. I don't name these things, I just talk about them. So here's that more complex view again. The same view you've seen twice already. You're creating a new task. This is just how you do it with Pyramid. And the only thing that really changes is that your request now has a DB session on it. You're not committing your changes. And if you want to build your response deliberately, you take your response. Did I not do this correctly? Oh, no, here it is. OK, cool. You take your response from the request object, which is a weird concept, actually. But you take your response from the request object, you set a header, set a status code, Pyramid will know, and then you send your response back. But again, it's the same operation you've now seen twice. You're just creating a new task in this application. Let's talk about Django. I imagine many people who do web work here are familiar with Django. If you're not, it's kind of the big daddy of web frameworks in Python. It's a Python package like any other, so you pip install Django. I also use DJ database URL to easily parse my databases URLs instead of setting it up as Django would have me do it. Django's funny in that it sets up an ecosystem for you. It assumes you want to do a lot of stuff, And it'll give you those tools, and if you want to do anything outside of that framework, it'll yell at you or make it very difficult to work. Which, double-edged sword. Yeah, but then that's more work for you. There are a lot of settings in Django, which I'll get to in a minute. Your URL configuration will be in a separate file somewhere, usually called urls.py in your project, your application root, in the same directory as your settings. You have to set up your debug and secret key. I thoroughly recommend that you take your secret key and move it out of your settings because it's secret, and if you try to commit that, you're letting a secret out into the world. And then I use DJ database URL to parse my database URL. You don't have to do that. I just prefer to do it that way. And then when you're in development mode and you want to run or do any central control like manage your database or run a server or run tests, you're always going to go through this manage.py file, which is callable, which is a runnable script from the command line. So you can say manage.py space whatever command I want to do, like run tests or run my server or whatever, and it'll do that thing for me. Django has a lot of settings. I've truncated the vast majority of them because they're not as useful for this talk. The things you got to be concerned about as developers building an application from scratch are these ones. Your secret key should be secret somewhere in your environment. You set it up to be whatever. Debug should change based on whether or not you're in production or in development. If you're in development, you want debug on. You'll see nice debug pages which tell you exactly what errors you had, as well as a bunch of other stuff you didn't know you even had as a part of your web framework. You also need your allowed hosts list. Now, in development, you don't really need this, but in production, you do. In fact, Django will not work if your allowed host list does not contain the host that you are currently serving your site from. Important to know. Your installed apps list, which doesn't really make much sense right now, but will in a bit, it'll contain all of the apps or the smaller modules that Django will handle for you. And it's the only way that Django will know about if a model exists in your code base. If you don't include it in this list, it doesn't exist. That rhymes. That's good. Any databases you want to have must be a part of the database's keyword. Again, there are about a dozen other settings you can have by default, and many more if you want to have any third-party applications in there. But these are the ones that matter most for a basic Django web application. Now, Django comes prepackaged with its own ORM, Object Relational Mapper. That's what SQL Alchemy did for us before. It is the intermediary between us and your SQL database. It is so that you don't have to write raw SQL and do your own sanitization of user input, which is nice, to a point. Now, if you want to use something like Mongo, your life's going to be hard, because Django, by default, assumes you like SQL. In fact, it thinks so much about SQL that it structures the way that it builds models based on SQL, the way you'd write a SQL query. It does not like NoSQL. You can force it into that hole, but it's not going to play well with Mongo. There are packages now for it that work better. I don't know them very well, but I've heard some horror stories. Any model that you want to have must live in an app, a Django app, and that app that you create must be in your installed apps list, as I mentioned before, in settings.py. So when you're building a model in Django, even though it's its own system and it works in a somewhat different way, it looks very similar to what we've already seen with Flask, Pyramid, and Tornado. Instead of the DB object, or instead of the base object, we now have the Django model object, which is the thing that all your models inherit from. Instead of columns, you have fields, but it's the same exact idea, where you're going to instantiate a field object as a class attribute, and that's going to be your column in your database table. Then there's going to be some keyword arguments you can set to be things like primary keys, or if you can take null values. And the one other major difference is that you don't have to make your own user object. Django is used so often to make user model relationships that it just has a user model for you, with password and username and whatever you want, email if you want that as well. So you don't have to make it. So this is the one model I have to make for Django. You've seen this format before. The one thing missing here is the ID, because Django automatically assumes you want to have an ID that's an integer, and it'll auto-increment it up for you. But everything else is just a field on your model. Relationships are also fairly simple in Django. Because it assumes you like SQL, it has a bunch of SQL tools for you, built for you. Things like this foreign key object, which says, give me the one thing my many will talk to, and I will make a relationship for you. You don't have to worry about anything at all. To initialize your Django database, you say, hey, I'm going to make some migrations, which are kind of like a snapshot of how your models exist right now. And then I'm going to migrate those snapshots into my actual database. So when you say make migrations, you're saying I'm going to take a record of everything that I have set up in my code. I'm not going to commit anything yet, but I'm going to have it there for when I do commit things. And then when you say migrate, now you're saying take those snapshots and apply them to my database. Make those tables in that exact way that I said. And when I want to update those tables, make migrations again and then migrate again. Here's a URL configuration. In Django, you must make this URL parameters list, which makes URL objects out of your patterns, your views, and your the name of the route. Here is a class-based view in Django using Django REST framework, because all these are REST APIs. But it's the same sort of idea. You've seen this view before. It's just like the same thing you've seen with Tornado. With Django, the request object is now a part of your class-based view. It becomes an attribute. Your route variables are passed to your methods as parameters. They are not going to populate a dictionary like with Pyramid. Your models themselves contain the database connection. So there's no more session you have to manage on your own. You just say, whatever my model instance is, save that thing, now it's committed. Or if you want to delete that thing, then delete it. And this is that same task creation view as we saw it with Flask and Pyramid and Tornado. The main difference here being that you have a user object already that's built for you by Django. There's no session to worry about. And all your post data comes from this post dictionary. And that's it. So after doing this and learning these other two frameworks, these are kind of my impressions of the four of them. Flask is great, but only if you want to do very, very small things. If you want to make it more complex, if you want to add a bunch of models, if you want to do a lot of complicated things, Flask becomes a pain to work with. Tornado is kind of sits between Flask and Django. It looks like Flask with its do-it-yourself nature, but it has class-based views like with Django. It also has a little asynchronous bit, which makes it unique. Pyramid is great if you want to grow a project from a small starter. And Django if you like relational databases and a million files open at the same time. But it's good for big projects. And I would honestly choose probably no other one if I'm starting out with a big project. That's it. Thanks for listening. I know I can talk a lot. That's my kid!